The SPI protocol, or Serial Peripheral Interface, is a synchronous protocol. It uses a dedicated pin for the clock, which is the SCLK pin. This one is generated by the master, so the clock will be generated and outputted by the master and will be received by the slave. And this clock pin will be used to synchronize the flow of exchange of data back and forth between the master and the slave. For the data exchange itself, the SPI protocol has two pins, MOSI and MISO. MOSI stands for master output, slave input, and MISO stands for master input, slave output. If the master is the one to send the data and the slave is the one to receive this data, then the master will output the data via the MOSI pin. On the other side, the slave will receive the data via the MOSI pin as well. So the master output channel must be connected to the slave input channel. Similar to the send routine, if the master wants to receive data from the slave, it must connect the MISO pin of the master to the MISO pin of the slave. So this master input channel must be connected to the slave output channel. This is the reason why we have this direct connection between the MOSI to the MOSI and the MISO to the MISO, because each pin has dual functionalities depending of course if our SPI is a master or a slave. So for the communication between a master and a slave, we'll have this direct and explicit connection between MOSI to the MOSI and MISO to the MISO. Finally, we'll have this last pin, slave select or ship select. This one will be used in case we'll have a bus topology that consists of single master, multiple slaves. In this case, the master will be able to select which slave is going to communicate to via this pin. So once this pin is pulled down, the connected slave will be active. So this is an active flow pin. So if this line is going down for this selected slave, it means the master will communicate with this one. If this line is going down, then this is the slave to be used to communicate with our master, and so on. When it comes to the SPI bus topology, we can have a single SPI master connected to multiple SPI slaves. The way the SPI master will select which slave to communicate with will be via this slave select pin. In this example, we have 3 slaves connected to a single SPI master. if we want to communicate with the slave number 1, then we need to pull down the slave select pin number 1. If we want now to communicate with the slave number 2, then we need to put back the slave select pin number 1 up and pull down the slave select pin number 2. The same sequence for the slave number 3. So this line is active low. With this approach, we can have as many slaves as we want connected to our single SPI master. The only drawback will be that we need to allocate many pinouts to our SPI slaves to connect many slaves. Hence, the amount of slaves to be connected as part of this SPI bus topology will depend on how many slave select pins we can associate within our SPI master. If you liked this video from WADX Technologies, please feel free to subscribe to our YouTube channel for more embedded systems related videos. And please feel free as well to check out our website www.wadxtech.com for more free blogs, articles, tutorials, as well as online courses. Thank you.